Apple Talk, IP, Novell, and NetWare, etc. But in fact, now the most used network layer is the IP protocol. Some students will ask, can static routing be considered an IGP protocol? Okay. For static routing, it cannot be considered an agreement. A static route is just a single static route, because it has no algorithm. It also does not need to specify a range. Static routing can also be used on the public network, because it is not an algorithm. So it does not belong to the IGP agreement, or the EGP agreement. Let's explain IP. The others are not commonly used now because we're not going to explain. For the IP protocol, the first thing you need to know is, when we are talking about the third floor, I actually told everyone, the IP protocol we are using now is IP version 4, Internet Protocol version 4. We now also have an IPv6. You may be interested in IPv4 and IPv6. It's more about staying on the IP address. But the IP address is actually a field in the IP protocol. A source IP and destination IP is a field. Actually, what we're talking about, IPv4 and IPv6, the two large framework protocols. Then why is there only one IP written here? Is it because we still have to compare with OSPF? What OSPF learns in the NA and NP stages is version 2 of OSPF. So in fact OSPF also has version 3. So for the current IPv4 network environment, when running OSPF, in fact, version 2 is used. If the IP protocol migrates to version 6 in the future, let's run OSPF to use version 3 of OSPF, because there are some mechanisms in version 2 and version 3 are different, and for different IP protocols, what it serves is also different. So, if the future really migrates from version 4 to version 6 era, we are now deploying IPv6 addresses on a large scale. This is the overall transition. If in the future, we hope to see single-stack IPv6 all over the world, relatively speaking, it is still relatively long. Have to be decades. Single-stack means IPv4 is completely useless. IPv6 only. In fact, this is a very long process. But for the present process, if it really came to that age, IPv4 has really migrated to IPv6. When you go to use OSPF again, version 2 cannot be used. Can only use version 3. That is a transition issue between protocols that I highlight. Protocols like OSPF. It is impossible to make a smooth transition. You have to completely modify the current overall configuration. Because the version is different, the configuration is also different. It has no way of smooth transition. But why bring it up and talk about it? Because of EIGRP it's not the same. EIGRP is version agnostic. That is, whether it is the current version 4 or the future version 6. No matter which IP protocol you choose, EIGRP works as usual. It also does not need to modify the configuration. It is unversioned. So in the future if the transition, it can do a very smooth transition. Updates with little impact on configuration. It does not serve version 4 or version 6 alone. Here's the difference between them. Next, let's talk about its characteristics. A lot of this is nonsense. I pick some key ones. First let's talk about this advanced distance vector. It is an advanced distance vector routing protocol. Look here. It is a distance vector routing protocol. It's just more advanced. Where is the senior? I just said. For RIP. It's like someone gave it a cooked meal. It ate directly. It looks at the devices at both ends locally. Then send the data to others. But for EIGRP are different. For these devices, it is also the interconnection of multiple devices. This is R1. This is R2. This is R3. After R1 calculates his own, directly give to R2. Then for R2, it will take in R1. After that, it is not calculated locally before sending, but after taking it in. Take your own and send it directly to the other party. Then calculate it yourself. Every device is like this. So, its overall sending speed is much faster than RIP. Of course, from the point of view of what we just said about eating, it doesn't really make a difference, because it also passes the routing table. But it's coming soon. It will not be counted and sent after it is received. Instead, after receiving it, I even take my own and send it out together. Then run it locally. It's an algorithm question. The specific algorithm will focus on the NP stage. Algorithm is not as simple as I say now. In the NA stage we don't need to know much. Secondly, it has a feature. Fast convergence. EIGRP has a table called the topology table. If you have learned OSPF before, you probably know that OSPF also has a topology table. But it is not as strong as EIGRP. Topology table in EIGRP. It can put some backup paths inside. Pay attention to my words. You can put some backup paths. What are these paths used for? If there is a problem with the main line in the future. For example, data to destination. I will not draw the device between the two lines. Above is the main line. Here is the backup line. Once there is a problem with the main line, the alternate line will immediately appear in the routing table. Notice, is immediately present in the routing table. Then achieve a fast convergence. Let me tell you. How is this different from the static we just talked about? Some students may have doubts. Then the static interface was broken just now. Didn't the other one appear immediately? Do you all have such questions? Just now that also appeared immediately. But it is not the same as dynamic routing protocol. The one that appears immediately is due to your manual configuration. A separate backup path is allocated there. This is a static configuration. Please pay attention. This is the configuration. And for dynamic routing protocols, the backup line is calculated by itself. I guess it's a backup line. It is calculated. It's not one of your configurations. So for EIGRP, it can now calculate the data in the network. For example, there are multiple routes to the destination. And it can choose if this line meets the principle of entering the topology table. We can put it in the ellipse topology table. If the main line fails, I can immediately make this line appear in the routing table. And forward. It's a really nice mechanism for it. OSPF can't do it. Achieve a fast convergence. How can it be achieved? What kind of lines are eligible to enter the topology table? That's a question we're going to talk about today. Including here is another one called loop-free routing. I will tell you. Whether it's what we call EIGRP. OSPF is also good. ISIS